I'm going to be talking about incorporating some of the MapleSoft tools, mainly the calculator app and also Maple Learn, and how I've been using that in my, let's call them lessons, in my YouTube videos, basically, where I'm teaching maths. And the hope is that hopefully this will give you some ideas. If you're also a teacher or an educator, this might give you some ideas of how maybe you could do that yourselves. And if you're a student, maybe it just gives you some ideas about the features that these tools have and perhaps how they can be useful for you with your studies. So I did think that I would start, there we go, by telling you a little bit about my research, in fact, a little bit of background sort of to how I got to where I am at the moment. So this is a video taken on a GoPro camera on board a ship. So this is the James Clark Ross, which is a research vessel at the British Antarctic Survey. I think it's now been retired. And this is me going outside with my camera on my helmet, trying to film a tour of the ship, originally designed to be for my parents, which I did send to them, but now I use it in my talks. And I was on board this ship for a total of 6 weeks doing research. And the research was looking at climate change, climate models. And the idea was that we went to the Southern Ocean, so the ocean around Antarctica, for a couple of reasons. So first of all, it is the least influenced by humans because it's, of course, quite remote around Antarctica. And therefore, we could see how the Earth was reacting to the change in climate. For those of you who are paying attention to the video and not me, you'll now notice I'm running inside because there's a giant storm. You can tell when I spotted it because that's when I turn around and start running. And that brings me on to my second point of why we went to this ocean, because the Southern Ocean is actually the stormiest ocean that we have on the planet. And we went in April, I believe it was, which is the autumn, the start of autumn or fall in the Southern Hemisphere. And so this means that the ocean, had as much energy as possible. It had been heated for the entire summer period. And so therefore it was very, very stormy. And the reason we wanted storms is because the storms come in and they mix all of the water together. So sometimes you get separation in like fluids. So you see this sometimes in still water, like lakes and things. You get sort of like separation into layers. And the similar things can happen in the ocean, but we wanted it all mixed together to collect data for our samples that we could then compare to climate models that were being done as simulations and done on computers. So that was a little bit why we were there and what I was doing. And that is, my research is in fluid mechanics and is looking at a slightly different problem of ocean pollution, but still all tied into, the big issue facing us currently as humans of, we've kind of ruined our planet. Can we try and not do that? And can we use maths to help us try to rectify the situation a little bit? So that is a little bit about the sort of research that I actually do. Then when it comes to how I got into teaching and how I got into doing YouTube, this kind of happened by accident. I was actually talking with my colleagues at MapleSoft before the webinar about the fact that I never in a million years thought this is what I'd be doing at all, had zero plans that this would be what I was doing, and yet here I am. But that's not in any way a bad thing. So when I was doing my PhD, I actually did an internship with the BBC and a radio production company that made a weekly radio show for BBC 5 Live. So it's a national station in the UK. And the idea there was to take breaking science research and make it understandable to the general public, as in people listening to BBC radio on a Sunday afternoon. And it meant that I got to interview lots of really cool, interesting scientists, and also at the same time got really trained in taking or helping the interviewee to take their very complicated cutting edge research and explain it to a complete non-specialist. So I felt like I really improved communication, and also really helped me when it came to teaching, even though I obviously wasn't teaching at that exact point in time. And I then, finishing my PhD, I really enjoyed doing this internship, and fortunately they enjoyed having me. So when I finished my PhD, I went back and worked there for a year. We actually started working on a video series, which unfortunately never got released, but I do have the trailer which I just thought I'd share with you all. I just can't see my play button. There it is. Okay.
New from the Naked Scientists, it's Naked Maths. I'm Tom Crawford. This week on Naked Maths,
Talking about waves.
we're going to be delving into the world of architecture. We're finding out how the tiger earned its stripes. We're making good vibrations. I'm meeting the mathematicians of nature. We have famous faces.
Children love thinking about infinity.
How do you catch a lion in the desert?
We have bees. It's incredible. We have maths tattoos. And of course, we have fun.
So the idea of the video series was very similar to what we were doing on the radio show, but branching out there into video, which was to take complicated ideas and make them as explainable and interesting and understandable as possible. So as I said, started working on this project. It never actually happened in the end. But then I realized that I really missed actually doing maths. So, I'd only been 9 months out of my PhD. And even though I knew I didn't want to necessarily, or at least I didn't think that I wanted to necessarily continue in research and academia, I just sort of missed sitting down and just solving some maths problems. And I sort of began to realize, well, how can I do that and also continue to do this kind of science communication that I was currently doing as my job and was really, really enjoying. And that's basically how Tom Rocks Maths happened. I realized that maths is a lot easier to explain with visuals. It's very difficult to talk about maths on the radio. It's definitely not impossible, but it's very hard because sometimes you just need to see a shape or you need to see an equation, right? It's as long as you've explained it well anyway, you can display the equation. Sometimes you just need to see something written down in front of you or a calculation. So that's kind of the position I found myself in. And I decided to take a job and come back to Oxford, actually, where I studied as an undergrad and start teaching. So I started teaching at the university and then did that for a couple of years. Oh, losing my headphone. Did that for a couple of years. And then as my channel grew and Tom Rocks Maths became more popular, was then fortunate enough to actually agree with my college here in Oxford to make the YouTube stuff part of my job. So I can, which is a ridiculous thing to say, like officially part of my job, half of my job is like produce YouTube videos, actually being employed by an academic institution, which in itself is awesome. And obviously, I think my students enjoy the fact that I also do things online and stuff. At least I hope they do. They tell me they do. And some of them definitely comment on the videos saying like, see you tomorrow, or I remember you teaching us this last week, and things like that. And I think it's really actually helped me as a teacher to obviously, and especially because I was doing this a few years before the pandemic and everything went online. So I kind of was very fortunate. I already had the tech, the setup, the skills to actually be able to teach, hopefully quite effectively online. So
New from the Naked Scientist.
Don't play again. So as I said, that's where I am at the moment. It's now officially part of my job at St Edmund Hall, which is the college where I work over here in Oxford. Now, obviously the purpose of, or the main purpose of this webinar is for me to talk a little bit about how I've worked with MapleSoft and used both the Maple Calculator app and Maple Learn and incorporated them into my YouTube videos and teaching. So I figured the best way to sort of talk through that is more or less to just show you some clips, talk through like my thought process behind why I thought about using it in this way, and a little bit about the feedback I've had from some of the students, either online or my students in person. So I've in total produced, I think there's seven videos at the moment, which feature Maple Learn or the Maple Calculator app. As you can see, I decided on purpose to kind of group them together under Oxford Calculus, because basically what I've done is take the first year calculus course, Introductory Calculus, that we teach in the first term to our first year undergraduate students. So it's completely, obviously, compulsory course. They all have to do it, and it starts as soon as they arrive. And I've taken a lot of the ideas in that course and then basically just taken the lecture notes and turned them into short videos. So I'm maybe about halfway through the course, I think, with these sort of 6 videos. The one called Christmas Calculus was just me having a bit of fun because it was Christmas, and I figured, why not do something a little bit different? But the other 6 are about half of the course or so far, and it's kind of like a lecture. I introduce the topic. As you see, there's a range of different things. I kind of introduce the topic, go through an example or two, and then at the end incorporate a worksheet and some kind of almost like homework questions, of course, completely optional if you're just watching this on YouTube, for the students to do. And those exercises are based again from what the problem sheets are that we're giving to the students here in Oxford. So I've kind of tried to almost like, in some sense, it's like what I imagine lots of other people are having to do with moving all of your teaching online, but I'm also trying to do it for like a YouTube audience, as well as hopefully for my students. So I know that in particular, the one about classifying critical points using the discriminant, the third one on that list, I know that all of my students last year loved that and said that was really, really helpful and better than their lecturer had explained, which was really nice to hear. So it kind of, whilst it's not a formal part of the way that they're taught, because I'm literally using the same material that they're seeing in their lectures, a lot of them are finding it very helpful to then be able to sort of have me teach it to them online, as well as obviously in our classes. Now for the actual, so something that I found interesting looking at the stats for these videos when I was putting this talk together today. So the first one on partial differentiation is the most popular, or was the most popular. That one's got about 70,000 views. The 2 critical points ones are about 10,000 each, I think, because they're a little bit more advanced, a little bit more specialized, perhaps. The integrating factors one, I think, has got about 30,000. Solving PDEs is about 30,000. And then Jacobians, only came out 2 weeks ago, has already got 70,000. So apparently YouTube has loved the Jacobian one. So I found that interesting, but at the same time, it's perhaps not too surprising that 2 sort of key topics that probably any student doing anything mathematical at university has to learn about will be partial differentiation. For example, that's going to come up a lot in like economics and other things, probably in a lot of the sciences as well, and also Jacobians. So I would have guessed that those 2, maybe integrating factors though as well, because integrating factors are introduced a little bit, at least in the UK, at the end of high school maths. But they've been the 2 that have been the most popular, partial differentiation and Jacobians. Now, in terms of incorporating the Maple software, so again, I've got a few little clips. So I'll show you the clip, and then I'll talk a little bit about, where the idea came from or how I thought to use it in that way. So here's the first one, and I think this is from the critical points video.
You can actually do this with pretty much any function you can come up with using the Maple Calculator app on your phone. It's completely free to use, and I do strongly recommend playing around with it to try to get some intuition into the different kinds of surfaces you can create with functions of 2 variables. All you do is enter z equals your function in terms of x and y, and then select 3D plot to see what it looks like. The example I have here is z equals x squared plus 2xy minus y squared plus y cubed. Looking at the 3D plot, we can see that it appears to go flat around the center, and so 0 could perhaps be one of our critical points.
So, as I said, that's just a little sample of one of the first ones I did, in fact. And that one, I thought in particular, was incredibly helpful to aid the learning process, because in the video I'm talking about, here's a function of x and y, where we're interested in finding the critical points, but what does a critical point look like for a 2D function? So I sort of start by motivating through an example of a 1D, a y equals f of x graph, and talking about, well, a critical point is where it goes flat. And then, but then obviously my artistic talents do not extend to being able to draw, well, they're almost non-existent, but I definitely can't draw 3-dimensional functions. So being able to use the visualization feature there in the calculator app really helped me when I was talking through the video, be able to show and sort of, because I'd motivated it through the fact that the thing goes flat, it then sort of I was teaching it in a visual way. So then being able to see that 3D plot was really key, I think, in sort of driving home that point that we can, just by looking at the shape of the graph, we can have a guess and have a bit of intuition about where those points might be that are going to be the critical points. And as you probably guessed, that what 0, 0 was, of course, one of the critical points for that function. So that was one example where mainly focused around the visualization aspect of the calculator app. The next one, so this is from the partial differentiation video, the most popular one. And here I was sort of, encouraging the viewers and my students to have a go. So I talked through what partial differentiation was, how it sort of, you can see there the limit definition, and I sort of again motivated that based on their current experience of the standard full derivative, and then the idea here was I'd written this function and said, right, here's sort of how you calculate some of these partial derivatives, and then we're sort of saying, right, now you need to go away and you need to practice this. But of course, one of the things when you're doing that in a YouTube video, so obviously I'm doing this with my students, right? I give them a list of questions and they go away and do them. But when you're doing this in a YouTube video, you can give people a list of questions, but they can't necessarily check their answers. And so here I was saying, well, it turns out that you can check your answers, again, using the calculator app, which I think is a brilliant tool for actually checking that what you're doing is correct, or maybe even doing the derivative for you in the first place if you're struggling as a student and can't even think what the answer might be.
And I do recommend trying this out for yourself to get practice with doing partial derivatives of higher orders, maybe with mixed derivatives. So just pick any function f of x, y, you can plug it into the Maple Calculator app, and it will automatically tell you the x and y partial derivatives of the function once you enter it into the app. So you should do it yourself first, and then you can use the app to check your answer and sort of mark your own work and see if you're beginning to grasp how partial differentiation works.
I think I've got one more example.
And I do.
Yeah. Also, it's quite entertaining watching this myself because these are all within the last year, and just like the number of different hairstyles that I'm going through is quite something. Blame lockdown. I had to create excitement somehow, right? So this one is the integrating factor video. Again, you probably see from what's written on the board. So again, this is another feature that I thought was really, really helpful, both for mainly for students, again, for checking what they were doing. So I think here it was about doing the integral. So I was trying to like derive where the formula for the integrating factor comes from. So starting from this general equation, rearranging it, and then separating variables and integrating, sort of what I've gone through there. And obviously you've got this e to the minus the integral of some function p. And then I was saying, right, so try this for a few different p functions. So go back to your original ODE, write something down with a function p of x, could be whatever you want. And then, of course, you're going to have to integrate it to be able to figure out what the integrating factor is before you even try and solve the differential equation. And again, the fact that you can obviously do that in the calculator app is really, really helpful. So,
of course, we still need to integrate our function p of x, which again will be given for a specific question. But fortunately, we can check our working using the Maple Calculator app. All you do is click the integral sign and then input our function p of x, and the app will do the integral for you to allow you to check your answer. And if you're struggling when doing the integral for yourself, then you can even click on the footprints icon and it will show you the steps involved to get to the solution.
And that steps feature is also really good. So I know that's been a recent addition, which is great because, you know, as well as giving you the answer, obviously being able to actually see exactly how you did it or where the answer came from is obviously really key to that learning process. So I think that's like, you know, the kind of thing that's very difficult to replicate through sort of teaching on YouTube. Again, with my own students, we can sit down and we can go through those questions and figure out the steps. But when you're teaching online on YouTube, I think it's really nice that the app kind of fills in those gaps for you to, to help the students kind of follow what's happening. So there's some examples with, as I said, the calculator app. So the visualizations, I think, I've used that kind of concept quite a bit in a lot of these videos, just because they're really nice, they're really good to be able to see what's going on. And with a lot of the ways that I teach, I'm trying to build that intuition a little bit, rather than just saying, this is a technique, you use it. It's like, well, where is this coming from? Why are we doing it this way? So I think being able to see the functions and visualize what you're doing, I think is really, really helpful. And then, of course, it's great as well for checking answers for integrals and derivatives. Now for Maple Learn. So obviously this one is a bit more advanced kind of stuff we can do in Maple Learn. So I'm very much still learning, figuring out all of the things that I can do. And as was mentioned at the beginning, Nadia is here to answer the very, very technical questions about how you figure all of the bits and pieces together. But the things I have managed to do so far, I've got a couple of examples to show you, and I will click actually on the worksheet as well and sort of show you it live. So the first one here, this is the partial differentiation video again. So this was, once we got to the end, I then sort of, as I said, I've taught through the definition, gone through some examples, and then it's that bit at the end where it's like, right, and here's like your homework assignment, or here's where you can go and practice this. So what we did was put together a worksheet with some questions, and then also put together an answers sheet. So the students could have a go, or the viewers could have a go at the questions. And then there was another link to a separate one that had the answers filled in for them. So again, it was for them to be able to actually check their work. So here's a little video clip sort of demonstrating the problem set.
If you want some more practice with partial differentiation, I've actually set up a worksheet in Maple Learn, which you can access completely for free by clicking the link on screen. So there's plenty of questions for you to have a go at, plenty of partial derivatives for you to calculate, and remember, you can always check your answers by entering the function in the Maple Calculator app, as this will automatically calculate those partial derivatives for you.
So that last question, as I'll click on the worksheet in just a moment, or the answer sheet, the last question in particular was great in Maple Learn because as well as doing the derivatives, obviously in the question I've asked people to also have a go at sketching it. And again, that's exactly the kind of thing that you can do with this. Oh, that's the one. So if I click this, then hopefully we will load the answer sheet for those questions. There we go. So obviously the first few are just about finding partial derivatives. As I mentioned in the video, of course, this is the kind of thing students can check this themselves anyway, just using the calculator app. But of course, it's quite nice to have them in a different color as well, so they can clearly see what the answers should be for all of these things. Then question 2 was looking at mixed partial derivatives. So calculating a few of them and seeing that sometimes they're the same and sometimes they're not, or I think they might all be the same here. Can't actually remember. But again, obviously we've got some of those answers there. And then the third one, which I think is the best bit about this particular set of answers and using Maple Learn in this way, was not only can you get the expressions, which are obviously quite complicated, with this being a real solution to the heat equation, but then being able to use the graph to plot what's happening. So the question asks you to plot this function. So it's like a Gaussian function, sort of the classic infinite spike of heat that's going to spread out over time. And you can, as you can see here, the sort of 2 plots. But not only that, you can also interact because you can change your constants up here. So you can change A, which is the peak of your graph. So as you increase A, obviously the peak gets higher. And then you can change K, which I think corresponds to the width. So yes. Oh, you don't want to go negative though. As you go positive with K, it gets wider. So it just kind of that interactivity and those sliders, I think, are a really nice way to help the students actually understand the function that they're plotting, as well as obviously checking their answers at the same time in the worksheet. Okay, and then the final example with Maple Learn. So again, this is from the Integrating Factors video. And this one was really neat. This one was definitely down to Krishma, one of the other developers at MapleSoft, helped put this one together. This is really nice because this actually generates questions in real time for people. So I'll just play the little video clip and then obviously I'll click the worksheet and we can give you a bit of a demonstration of what we did with this one.
For those of you that would like to practice the integrating factor technique a little further, I've created this interactive worksheet in Maple Learn, which you can access for free by clicking on the link in the video description. Have a go and let me know how you get on.
Right, so if I click this one, then I might have to actually do some live maths for you all here, won't I? Right, so it kind of starts with a little bit of a reminder of what I've been talking about in the video, you know, and saying here's a general differential equation, here's the formula for the integrating factor. And again, what I derive and talk about in the video is to say we can work out what the solution will be. Now, I actually personally wouldn't, and I talk about this in the video, wouldn't necessarily say to the students, just learn the formula. Because again, the way I'm trying to teach it is where does it come from and different things. But of course, we can get this is the solution. And so in order to sort of write down what the solution is, they need to be able to identify these two functions, P and Q. So what we can do here, where it says practice, is, as it says here, is a specific differential equation, find P and Q. So this thing looks exceptionally complicated. So based on what have we got? We've got d by dx of y plus p times y equals q. So what have we got? We've got e to the x plus this thing. So there's no y's there. So that's all part of q. That's going to be part of q. Then we've got a y multiplying something. Then we've got a y multiplying something else. So obviously you're going to have to identify which bit's p and which bit's q. And then, but we're also going to have to divide through as well by the factors multiplying the dy by dx. So, this is going to be exceptionally difficult. Let me try and do this one right. So I think, let's try q, because I think that's a bit easier. So I think this is going to be e to the x plus, can I just copy and paste this? Oh, maybe I can. Plus all of this. Right. I need another bracket. Okay. Right, so it's going to be that whole thing divided by, I think, the factor multiplying the dy by dx. This is the part where I just reveal myself to not actually be able to do maths. So it's dy by dx times, we've got an e to the x term there, and then we've got, that second one is an x cubed sine x, right? So I think, whoops, nope, don't want you at the top. Need to come back down, there we go, plus x cubed. Oh, no, don't go there. X cubed times sine x. Right, I think that's correct. You're probably all shouting at me in the chat being like, no, what are you doing? That's very wrong. Right, and then let's try that. So obviously P is wrong, but I think that's right for Q. If I click check, hopefully, oh no, it's apparently not. Okay. Don't do live maths in a webinar. Lesson learned. Right. But anyway, so you can type in your answers and obviously it'll tell you if it's right or wrong. And then you can click show solution and we should get what the answer should actually be appearing down here. Come on. Okay, apparently maybe it's not working, unless it's just taking forever. Right, let's try and generate a new one. Right, I think my internet's having a bit of a moment because it's trying to do 100 things at once. Right, so now we've got a new one. So then if I were to click show solution, fingers crossed, it's actually going to load it this time. There we go. Awesome. Okay, right. So it's identifying P and Q and what they should be, and also then plugging them into the formula as well to say what the final solution should be once you simplify everything as well. So it's really nice. Obviously, lots of these expressions are very complicated. I'm not sure exactly where they're pulling all of these functions from, but I think it's really cool that you can literally generate practice questions in real time. So there is quite possibly an endless supply of possible questions that could come up. And you can see, first of all, if you're right, and then if you're not, then you can also get the solution. And then obviously you can create a new question and go back. And I know that particularly my students really liked this. Not that they, to be fair to them, needed that much practice on integrating factors, but I was really keen to show this off to them. And they said it was really nice because, like, you know, they remember when they were doing this actually at A-levels, like, you know, with anything with maths, once you've done all the questions in the book, it's like, where do you go next? So they said it was really nice that you could have this source of questions that you can keep getting generated. Right, so the final thing I just wanted to share with you all was just a few of the comments and the feedback that I've had on these videos, and specifically about the app and stuff. So I thought this one was great, that apparently somebody thought I had made this app. But that's obviously nice. This one's lovely. Somebody's just, you know, saying never knew such an app existed on phones. So, you know, saying thank you for sharing it. And then the video that I posted last week as well. Somebody's saying I've already got it and it's really useful, especially for visualizations. So I just thought it was really nice that, again, the online audience as well are appreciating having access to these tools, and I hope the fact that I'm trying to incorporate them and make those sort of like lecture style videos a little bit more interactive and give them a way of practicing and testing out those skills. So with that, I am going to leave it there and hopefully answer some of your fabulous questions. So yeah, I'm happy to obviously chat about anything I mentioned or anything else in general that anyone wants to ask about. I think Michelle is going to feed them over to me. So if you do have any questions, obviously, as I said, please do share them. But otherwise, I hope that was vaguely helpful. And thanks for listening.
I'm going to start with a couple questions. How do you get students engaged with these online tools? Like, how do you find they're receptive to it? Do you find it takes a little bit?
Yeah, I think with my students sort of in person, I literally like when I showed them that integrating factor thing, it's just because I was really excited that, you know, you could generate real-time questions. So just, I think me just being like literally in our tutorial, be like, guys, have you seen this? This is awesome, look, and like showing them. So I think like that's how I did it. But I think it's showing them the value in the tool. And this is in particular with the ones when I'm interacting with the YouTube audience online. It's when I incorporate it into the video, it's saying like, look, you can literally visualize this otherwise really difficult to understand function, right? I personally don't have very much intuition at all for like functions of X and Y as to what they look like. So I think it's really helpful that it's showing them the value that it brings to their learning, right? And demonstrating, and not just saying, check out this app or whatever, but it's actually showing how it can be used to help them solve problems and help them understand what they're being taught. That's always what I've tried to do with it. But also just being really excited about it because I am.
That's awesome. Nadia, I see you have joined us here and I was actually going to call on you. We have a question from an attendee who's wondering if a student needs a Maple account of any kind to use Maple Learn. And correct me if I'm wrong, because you are the Maple Learn expert, but I'm pretty sure that the free version of Maple Learn does not require any sign-in, anything like that.
Exactly. You can just open the link, so the Maple Learn link, and you don't need to create any account. You can start using it. But as Rochelle said, like the only thing is that to get access to the premium version, then you're gonna have to create an account. But the free version is, yeah, totally free to use. No need to have an account or anything like that.
Yeah, it's awesome. Now this is a really good question. Do you find that students see these apps as black boxes? They get answers by magic and have no idea what's going on. Why should they care about finding the answer, I think is the question here that's being asked.
Mm-hmm. So I think, first of all, the steps function is a great way of like trying to counter the black box argument, because, you know, before, if you're trying to do an integral and you can't figure it out, and then you think, or maybe, you know, you're, as a student, you're doing an integral and you get an answer and you want to check, is it right? Then of course you can plug it into one of many apps, Maple Calculator obviously being one, and see what the answer should be. But I think that if it's fine if you're right, because then you're like, great, move on, I do know what I'm doing. But obviously if you're not, then just sort of being given the answer obviously doesn't teach you how to then fix what you've done. You know, it tells you to go back and maybe check what you've done, but if you can't spot where something went wrong, then I think that's where the steps function is really nice, because, and I did a very brief demonstration in one of the videos. So like that actually shows you the steps. So, you know, if you were doing, I don't know, the integral of cos squared, let's say, you know, it would say step 1 is you're going to substitute that for the double angle formula of 1 minus cos of 2x or whatever it is, and then integrate. So it's like actually being able to fill in those steps, I think, is really helpful in making it feel like less of a magic trick and less of a black box that just gives you the answer.
Yeah.
As for the visualizations, I mean, I don't know, because as I said, I don't really have any intuition for what 2D surfaces should look like, beyond sort of basic graph sketching skills of what happens at infinity and 0 and stuff like that. Otherwise, but I think there perhaps, you know, the question isn't necessarily, or sorry, you're not necessarily using the app in that context to just kind of get the answer. You're using it to try and improve your understanding of what the question is asking you to do, right? You're not going to get a question that's going to say, draw this 2D surface or whatever. It's just going to be that having a visual aid, I would argue, is really, really helpful. I find it super helpful to then actually have a bit more of an idea of what's going on and what you're doing.
Yeah.
So, you know, I think, as again, I think the steps thing helps to remove that kind of black box aspect. And it's more of like a tool to like aid your learning rather than just, you know, give me the answer. Because again, if I think it would be quite obvious if students were doing an assignment and, you know, just didn't have any working, but had all the answers correct, then it would surely be very, very obvious to their teacher or tutor that they've clearly just plugged this into an online calculator or an app rather than actually, you know, doing it. So, you know, there's still going to be some students who no doubt will try and do that, but I guess there's not really much you can do about that.
For sure. So I know you talked about this a little bit in your presentation, how the first few videos were based on a first-year calculus course, if I'm understanding that correctly. But how do you decide what you want to show and what you want to teach? Like, do you have a certain process you follow or anything like that?
So originally, I picked the topics that my students struggle with the most. That was my starting point. It's one of the things, it's literally the best source of material when you're trying to make educational YouTube videos, is what do my real life students that I see every week, what do they get stuck on? Because no doubt lots of other people will get stuck on that as well. Yeah, that's great. So that's a really good source for figuring out what content I should make and help people understand. Also, I think it's, as for me as well, it's perhaps when I have a slightly different way of interpreting or explaining a concept. So for example, the Jacobian video that I just made, I sort of tried to motivate that at the very beginning by looking at the change from Cartesian to polar coordinates. And there's so many people in the comments sort of saying, like, we just sort of were told you just put an R there, or, you know, or you calculate your matrix and the determinant is R, but they didn't know like why. Yeah. And like, so that was something where I personally have always thought about it geometrically. I've always thought you take a square and it gets stretched a bit into like a sector of a kind of circle thing, and you're actually just trying to work out the area of that. And it turns out that's where the R comes in. So it's things like that where when I'm teaching them to my students and you see that you're perhaps doing something a little bit different to how it's taught in a standard way, and you kind of see them suddenly get it. And after a few times of maybe that happening with different sets of students or different years, at least from my perspective, I begin to think, oh, maybe I'm actually teaching this or explaining this different to how other people do. And therefore that could be a valuable thing to make a video about, to give people that alternative way of interpreting a question or understanding a problem.
Yeah, that's awesome.
So yeah, so it's those main two things, I think. Something where I think I found something of explaining a bit different, or something where my students struggle, because then most others will probably be struggling as well. Very
cool. Nadia, I'm going to call you out of the ether again. So somebody is asked about if Maple Calculator is being updated and with new features and bug fixes and things like that. And I believe, well, you can obviously speak on this much more than I can, but yes, it is being updated all the time.
Yes, yeah, definitely. We update it regularly to add new feature and fix like bugs and things like that. So it's always actually supported to the new OS or that you're using. And also regarding your comment on the keyboard, one of the great feature about the app that Tom may not have had time to show is just taking picture of mathematical content. So instead of having to enter your expression directly with the app and typing it, you can just like write it on like a notebook and take a picture of it, because the app will just recognize any mathematical expression and import it directly in there. So then you can work with it, which make I don't know, doing math probably 6 or 7 times faster than the way you would do it on a computer or others.
I think it's important to note too that he comments that he's on an Android phone. They are supported on both Apple and Android, but each of those app stores have their own review processes and things like that. So depending on what the turnaround time is on that, there may be a difference in the features that iPhone has versus Android, and that's just dependent upon the app store regulations.
Yeah.
And then there's this question here, and Tom, you may be able to jump in on this as well, but Nadia, you would be a good one to answer this. Do you find the apps Calculator and Learn are of greater interest to engineers and science type students, or like a pure math type student?
I can reply. I mean, part of it, Tom. I think you also I need your input. But actually, I'm an engineer and I work a lot with engineers, and they use a lot actually those type of apps, because like part of their courses is also to do a lot of math, so integral, solving equation and this type of things. And because they don't have such a big amount of training and classes and hours of mathematics, they need actually to get some concept like really quickly. So those apps, those tools, those online software is actually widely used in this, I would say, the STEM areas, so engineering and other science subject.
I think they're really helpful for both types of student, but I imagine they're going to use them in different ways.
Exactly.
So I would think that perhaps, so this is in no way disrespectful to physicists or engineers, but they're probably just like, I've got to do an integral. Maybe they're not that confident, or maybe they just want to know what the answer is. So then it's like great to just, as you said, take a photo, get the answer, or check, is that the right derivative and things. Whereas, again, from my perspective as teaching, being a mathematician and teaching maths, I really like the way that you can use it as a tool to help your understanding. So again, coming back to the visualizations, that's my favorite thing about about it all, is the visualizations and like the sliders on the graphs and stuff, like we saw with that heat equation plot. I think that interactivity and the visuals is just a really nice, it's an additional tool that can aid your understanding. So I would, as far as I'm aware, again, based on the comments I'm getting on the videos and stuff, there's like, but all kinds of engineers, physicists, mathematicians, all kinds of students seem to be using it for, as I said, possibly for slightly different reasons.
another question we have here is if Maple Learn is strictly based in a browser or if there's like a user installed desktop client. And even I know that one. It's in a browser, right? I'm correct on that, Nadia. So yeah, it works in a browser and not any sort of installed software. And I believe it's, correct me if I'm wrong again, Nadia, but it's primarily, it works best in Chrome, but it works on all other browsers.
Yeah, Google Chrome is actually the preferred browsers compared to the other ones. Yeah, but also just to add to your question, because this is actually a question that we also get regarding using Maple Learn outside actually of a web browser to avoid like connection issue. So we're actually working on having potentially a fixed actually a client-based version of Maple Learn, because this is something that we are exploring due to like a lot of students not having access to internet during classes, if there is like exam or something like that. So, I mean, as it's a really recent and new product, this is something that is on the roadmap.
Yeah, it is a very new product for those who are unaware. And are students able to submit a Maple Learn file as an assignment solution?
Oh yeah, as a homework, yeah. I mean, basically when you use Maple Learn, so the student can work in the document and then in just one click, he can generate a link and share the link with his teacher in just one click, basically. He also has the opportunity to upload his Maple Learn document on what we call the Maple Cloud, which is our cloud actually platform to save actually any Maple Learn calculator, Maple-based document. So this is also an option to share document, but Maple Learn is really easy actually in a way that you just have to make a click and send this link to your teacher, tutors, or colleague if you want.
And Maple Cloud is a really cool function of this because you can create separate small groups. So you can create a private sort of class group in Maple Cloud to share, right?
Yeah, exactly.
Which comes in helpful. Oh, here's a great one. If you're already using Maple, what does Maple Learn bring to the table? Like,
you want me to answer?
Yeah. I mean, either of you.
I mean, same thing. I can start, and Tom, if you have anything to add, just interrupt me. So basically, Maple Learn is an online version of Maple in which we've integrated all the teaching and learning features of Maple. So basically, we decided to make really a product, an online tool that is focused on teaching and learning, while Maple is, I mean, for those of you who know Maple, it's a really powerful and really sometimes a bit complex software. So we really wanted to remove this learning curve of the software and make it available in a click, basically, for student, teacher who wants to use it purely for teaching and learning.
I've always thought of it as like the app on the phone is kind of like almost like the most entry level, shall we say, exactly. Like thing.
Yeah.
And then it's like, so you've got kind of like the basic one that will do a few little bits and bobs, really helpful for like, you know, taking photos and answering the odd question, visualizing.
Yeah.
But, you know, possibly can't do like really complicated matrix things and whatever else. And then you've obviously got Maple, the full Maple version, which, as you said, can kind of do anything. You just need to figure out, you know, find the right toolbox or whatever it is to allow you to do it, but you can probably do anything with it. So then I've always thought Maple Learn just kind of slots in between. So it's like, makes the jump less of a jump to going from simple on your phone to insanely complicated and powerful. It's kind of right in the middle between the two. So once you get used to and see some of the features and get more familiar with Maple Learn, then you can maybe, you know, you reach a point where you're trying to do more advanced things and like, oh, I can't quite do that here. So maybe I jump into sort of full Maple and do it there.
If anyone has any additional questions, you can email them to me at webinars@maplesoft.com. And I see Nadia is raising her hand.
Yeah, actually, it's just because there is one last question that
Sure.
I'm just gonna answer now. When a Maple Learn document is saved, can it be examined as a text file of comments similar to Maple itself? And basically, at the moment, Maple Learn saves on the cloud, on Maple Cloud. So we don't have actually files to examine like the same way we have with Maple Learn. And something like Maple Learn at the moment can't import to Maple. but you can import content from the calculator to Maple. So there is a link. So basically anything that you take in pictures or you work with on the calculator can be imported in Maple and in Maple Learn also at the same time. But at the moment, there is no direct link between importing Maple Learn to Maple. But the other way around works, which means that, for example, the document that Tom showed with the quiz and the exercise is actually produced from Maple. So you need to script those documents in Maple with the Maple language package and command to get actually this Maple Learn document.
And someone is wondering if they can have an extension of Maple Learn if they already have Maple.
No, actually, to get Maple Learn, it's a different type, I would say, of licensing. So you actually need to purchase your monthly, actually, premium access to Maple Learn. Yeah, but like we've said before, the basic version is free, does not require any extra sign-in or obligation of any kind, but there is a premium version with some added functionality there. Okay, well, I think that covers the questions. Again, Tom, thank you. And if we didn't get to your question, if I missed it somehow, I'm sorry. One. Two, you can email them to webinars@maplesoft.com and I'll try my best to get you an answer. And thank you for joining us today. We hope you enjoyed it and we hope to see you again soon.
Yeah, thanks everyone.
Thank you.
Bye-bye.